My name is Gustaf Nyman. I am from Stockholm, and I am developer, but I'm also a CEO of Apitech. We are a software company specializing in API management software. And this talk is about enterprise APIs. I wonder how many of you are working in an enterprise environment? Almost all. This is in the business track, but I will cover technical stuff too. So, what's so special about enterprise APIs? Well, enterprises, they have in-house developed systems, they have acquired systems, maybe they use software as a service, external, and they have a lot of different types of clients. And most systems need to communicate, and they expose some kind of API. An enterprise has many internal APIs and legacy APIs using old technology. I put a star there because I don't think it's that too bad. But my first lesson, if you're talking about enterprises API, is that you need to manage them. If you have 1, 2, 5, 10 APIs, maybe you can use it without having any central management. But if you count them in hundreds, 500, 1,000, it's essential. And my experience is that you need to have a single point API gateway. And that's not a single point of failure because you need to have clustering and load balancing on it. And you route from that gateway to the backend services. And sometimes you convert or translate messages. And the gateway, I think, is necessary too if you are going to use the microservice architecture. But another important thing of a centrally placed gateway is that it has to manage metadata. Because our experience is that you need to have control of the data that's communicated between clients and servers. And it needs to be machine describable. And you also need, if you have everything in the gateway, you need administration to keep track of routing configuration and metadata. And it's also important that you keep track of who's using who and how much. Of course, you need monitoring, and that's one of the key points with the API gateway. And the questions you need to be able to ask is, does it work? If not, why? Is it fast enough? And then there's some miscellaneous stuff like you need authentication, security, throttling, signing, validation, archiving, and etc. So I would say this is a picture of our API gateway. You have internal API servers and you have internal API clients. And sometimes you have external API clients from the internet. But in this picture, you also have external API servers. And we have experienced that it's very fruitful to put your external APIs that other companies provide for you behind an API gateway, because then you can have the same control and monitoring of these API. Because if they fail, you don't want your users to complain. You want to know it before they start to complain. So with the API gateway, you route messages to backend services. Sometimes you do protocol translation to support the legacy APIs, but you also keep track of the Whitelight XML schemas or Swagger JSON schemas. A very important use of the API gateway is for logging, monitoring, and analytics. And that's maybe the most important, because you will simplify monitoring debugging of connected systems. In an enterprise, you can't be sure if you have any logging on a backend system. And this way, at least you know if it doesn't work. And if you have an API gateway, it needs to have great performance and reliability. And one thing is that if you have a gateway, a lot of your users, they are developers, and they need to feel that this is the natural choice for me to use when I want to access services. Otherwise, you will have problems. So I start with a typical situation in an enterprise. You have a legacy API, and it's a monolith. It's queue-based transport. You have a text-based format, with just the data, message data structure and the values. You don't know, you can't see from the message what the values mean. And maybe you have 70, 80 different message types. And the task was to modernize this API. And you can do it in several ways. You can, of course, build proxies for all the 70 message types, but that's not really a scalable solution. So I've been working previously with using metadata to generate user interfaces. And I thought that maybe this could be usable in this situation too. At this time, XML was the most common format to communicate between different systems. And SOAP and Whistler was on its way to become standards. So I thought that maybe if we use XML schema to describe the structure and the data in this legacy message format, then we can convert it to XML with the schema. And fortunately, we came to have knowledge that the legacy system, the developers in the legacy system, they used a repository to describe all the terms in the relationship, and they generated their data structures. So it was a small task to just build an XML schema generator from the repository, and then all of a sudden we had 70 metadata descriptions of the 70 message API. So it looked like this. I don't know if you understand, but you have the clients use XML, and it passes the converter who reads the schema and converts this to another format, and then the other way back. And the converter is generic, and there's also a queue adapter to go from SOAP, HTTP, so to text and queue. And if you have an API gateway, these are the kind of stuff that you should be able to use as middleware in it. But this wasn't the end of it. In 2015, we needed to access the legacy API using modern tech. And the legacy API was SOAP over HTTP and an XML message format describing Whistler XML schema. So what should we do now? Should we get rid of the monolith and move to microservices? Well, we didn't, but we did another conversion. We decided to use JSON and Swagger JSON schema for description, and we built a converter between the XML and JSON using the XML schema, and generate the Swagger from Whistler using some simple mapping rules. And this is my lesson, my first lesson, is that use metadata. Metadata is a description of data, message exchange, and contracts, like Whistler XML schema or Swagger JSON schema, or other formats. And you have a lot of use for metadata, like you can validate data and message exchange, which is great, and will make your APIs more reliable, and you offload the servers. Many people use it to generate stub for clients and server code. And of course, you can generate documentation, which is great, test data, and even user interfaces. We used it to make the data format conversion. It doesn't always work. There are certain restraints on the data for it to be possible. But one thing to remember is about metadata and APIs is that you should design the contract, the API first, because that is really what is important. The implementation is a totally different thing. And you should really think before you generate contracts from code or tools, because then you might end up with schemas or metadata that's not comprehensible, that you can't understand them. We had another real-world business-to-business problem from the insurance business. At that time, a lot of the communication between brokers and insurance companies, they were sent on paper sign paper using surface mail. And there were a lot of papers for new insurances, salary changes, etc. And that was a situation that everybody wanted to get rid of. But if you have many companies that need to communicate, you need some sort of guidelines or standard. So it was a group was formed to develop these standards or guidelines. And the business requirements were quite simple. You need to have supply non-repudiation because the papers were signed, and of course confidentiality because we're using internet. And it should be simple to implement in any platform and language. So this was quite some time ago. But what we did, our selection was that we should use standards as far as possible, but we should also define how and simplify things. So we decided to use SOAP and HTTPS, and Whitelight and XML Schema to describe contracts. And for signing, we used web service security and certificates, and client certificates for authentication. We added a few things that was important that we couldn't find in real standard for, and a few standardized message type. And this, the last release of this standard was in 2006, and it's still used, and it's still the natural choice. You might think it's legacy technology, but in this case, it's not. It's simple. But one thing we learned from this, that the web service security standards, there are many and they're extremely complicated. And if you want things to last, you can't use everything in a standard. You have to select the good stuff. And the good stuff, that's what your business case needs. And I urge you to read specification. Don't rely on ready-made toolkits or framework. So if you build things that are simple, you will be able to migrate them or adapt them to new technology, is my belief. Another thing with APIs is that sooner or later they will fail. So if you work with an APIs or an API gateway, you need to improve an analysis and production debugging support. It should be an ongoing task. And I think that you need to log, and you need 3 different kinds of logs. You need the processing logs, and they describe what happened. What was the client's IP address, the HTTP headers, the routing information, maybe authentication, what was the response times from the server. The next thing is you need data logs. You need to save your messages at certain points in the execution. And if you just have routing, you save them from request and response. And if you don't have any response, you don't need to save it. And then you have the analytics log. And that is to answer questions like, what is the response time the last half hour or this month? And what service has the highest failure rate? But in order to this to be of value, you need to have a logging system that's always active. The most important thing is if you notice in your API gateway and operations, they notice that some server is crazy and just time out or return error code. And you call the responsible guy and he says, I have to go down to operation and change the configuration file for logging. And then my users will be crazy because performance will creep. So what you should do is you must have a high-performance log system, and it must be able to handle large amount of logs, especially if you have hundreds of thousands or maybe millions of transactions every day. And you must be able to find the logs too, so you have to correlate and cluster related log data. So what to log then? In Sweden we say logga lagom. You log just enough information. If you log too much, you can't find what you're interested in, and the logs become incomprehensible and unmanageable. If you log too little, the logs are useless. So my recommendation is to use an experience and an evolutionary approach. That is, if you debug a difficult problem, improve your log to enable easy identification the next time. And very important, always strive to enable less experienced personnel to effectively debug using logs. You can give hints if you find a problem, what might cause it. So the logging system that we used, it was always on, but we decided after 24 hours, you don't need all the hundreds of thousands of logs files. But if the system encountered an error, you saved all the related log files to disk, so you could at a later time look at them. Another thing with running an API gateway is that you have to take care of your users. And your platform should be the natural choice for developers. You need to make it easy for them to use them and they get value from using it. Otherwise, they won't do it. But in enterprises, you have more than developers. Many more are interested in what you're doing. And many users are not computer savvy. They need simple tools. They might not know what XML is. Well, maybe they heard about it, but they can't read the schema or they can't understand how it's used. So then you need to build tools for them so it's easy to access the information. And typical non-technical users are people responsible for some part of the business, testers that have extensive business skills, and they need to test your APIs. So they need help to create the test data. And then you have a golden opportunity again if you have used metadata, because then you can generate user interfaces using schemas that they can use to enter data and test your APIs. If you have a business-to-business communication where data is signed, you need to provide interfaces for it to people like customer service can access the data and find it and search it, and also present it in a readable form, because they're not interested in the JSON structure or the XML names. They're interested in the real data. Another thing is with old technology. If you work in the enterprise, you know that old technology they have a long lifetime. And I think this is a little funny, because it's always the next thing. And things get better, but there's also a hype in the industry that developers and architects, they want to use new things. But I think that you need to realize that everything will be legacy. It's just a matter of time. And maybe you choose to redesign, but I should recommend you if redesign is not an option. So to put legacy APIs behind converters, translators, and adapters, and then you can prolong their life and you can make the life of the client developers easy. So you can expose the modern APIs you prefer. So I think to be prepared for the legacy situation, you need to use standards. Don't avoid using toolkits that are like black boxes or vendor-specific extensions. And be selective. Do not use everything. You know, the XML Schema standard provides for every imaginary use, but you can manage with a very small part of it. And simplify. So your system will have a longer lifetime. So these are my lessons. You have to have an API gateway. Use metadata and you will be happy. Simplify and select. Monitor and log and prepare for system turning legacy. So You can contact me if you like on my mail address, and we have a booth downstairs. And don't miss my talk tomorrow, where we'll be showing build, deploy, test APIs and microservices with our products, Apitech Prisma. Thank you.
Thank you.